Hey there, so I'm going to show you a shortcut that you can do for all of these problems. That way that you only have one method you need to follow. So what you can do is always either for this one you can FOIL, and I'll show you how to do one of the other ones, and we'll end up into standard form. That way you only have one method that you need to remember. So when we FOIL this, we're going to do our first terms. We get x squared, outer, we get negative 3x, inner, negative x, and last is a plus 3. So we can simplify that down, and we're going to get a y equals x squared minus 4x plus 3. So this number that's all by itself here on the end, this number right here, no x's, that's going to be your y-intercept. So you can put that over here. What you can do is you're going to be able to erase this word and type in a 3 instead. Now when you're trying to find your axis of symmetry, the little form for that is going to be x equals negative b over 2a. So remember, this is standard form, so it's ax squared plus bx plus c. You can see what's going to be in that b and a area. So negative b is going to be negative 4, because our b is negative 4, over 2 times our a, which is 1. So we're in with 4 over 2, which is 2. So our axis of symmetry, we're going to write it out as x equals 2, because it's going to be a vertical dotted line at 2. You can also put your y-intercept on the graph while you're working on it. So then we have our y-intercept at 3. Alright, so far we found y-intercept, we found our axis of symmetry. So we do need to find a vertex, right? And our vertex is found through when you're working on your graph and you find your axis of symmetry. We're going to plug that back in. So I'm going to do it on the bottom. So we're going to plug in 2 and see what our output is. So we're going to plug in 2 to our function. So it's going to be 2 squared minus 4 times 2 plus 3, which is 4 minus 8 plus 3. So that's a negative 1. So your vertex is 2, negative 1. So it's like one of those things that sometimes it might not ask for it, but it's definitely something you're always going to need. So you can use that mirroring technique. So you can see how this is 1, 2 blocks away. So I'm going to go 1, 2 blocks to the other side. And we know that our x-intercepts from our original function, because remember, if you look at your forms, this is really intercept form. So this is your P and this is your Q. So those are actually going to be your intercepts. And you could always find that out from looking at the graph too. When we connect these, you can see how it's going to hit right at those values. So our x-intercepts are going to be 1 and 3. So that's how you can do most of these problems. Some of them are in, so they look like this. Maybe there's like a 2 in the front. Okay, so this might not be one from your problem, I just made it up, but just to show you how you can expand this. The first thing you need to do is to FOIL. Okay, and we're only foiling what's in the parentheses, so it's really like looking at it like this. Okay, and then you can FOIL those parentheses. We're not doing anything with that 2 yet. So we're going to end up with x squared minus 2x plus 1 after you FOIL that. Then you can distribute the 2. Remember, it goes to all of the terms on the inside of the parentheses. So we end up with 2x squared minus 4x plus 2 plus 1. And then you can simplify. So this is like an example for one of those other problems where it's not in standard form, but it's also not in intercept form. And then that'll be a plus 3. So these are technically the same graph. It's just this one is in vertex form and this one is in standard form. I hope this helps. If it doesn't, absolutely feel free to text me, or not text me, but email me, write me a comment on Google Classroom, whatever you need to do, but definitely don't hesitate to ask more questions.